You can use Python with IDEA in two ways. One is scripting, the other one is @python function. You can watch these two videos from ideascripting.com regarding how to use Python in the scripting mode. One is setting up Python to use with IDEA. The other one is IDEA script to Python script. In this video, we will be looking at how to use @python function. Before you start using Python with IDEA, we have to enable it in IDEA. So File, Options, Run Python scripts. So due to the open source nature of Python, backward compatibility for this feature is not supported. Yeah, I have read and agreed to these above terms. Click on it. I agree. Okay. Now IDEA is ready to be used with Python. So what is this @python function? How does it look? Click on Criteria, Character Functions, Python. Please take a moment to read through this help text. IDEA comes with a sample Python function called get%. I'm appending a field called x1, which is going to be a virtual character field with the width 10. @python get%. There are two parameters. One is sales tax, the other one is sales before tax. Let us validate. Yes, it's a valid equation. Okay, save it. Okay. So this is the outcome of using Python function. Let's take a look at the code. It's available in the library, current project library, custom functions, get%.py. This file in the file system is here. Documents, my IDEA documents, your IDEA projects, your project name, custom functions, and get%.py. Let's edit it. Right click, edit with idle. You can see the usage @python get%, sales tax, and sales before tax. What happens? Get% function is defined with the numerator and denominator as arguments. If denominator is equal to 0, return the value NA. This is a protection against division by 0. And once you get numerator and denominator multiplied by 100, you format with 2 decimal point and add a percentage symbol and return the entire value back to IDEA. You can test this function using run module. This will launch a Python shell where you can test your function. Get % numerator denominator 50%. Correct. Now let us test for the condition when the denominator is 0. Get %5,0. So in this function we have defined if the denominator is 0, we have to return the value NA. So we are getting NA. This function is defined with capital G and capital P. So if you invoke it like this, this is going to give an error because G is small, P is capital. So this is not matching with the name where we have defined the function. Next we will see the setup required to write our own Python code. We have to be aware of certain rules and conditions under which we could use Python with IDEA. Everything is provided in IDEA help. Let us launch the help system. Click on working with Python. Please take a few minutes to go through this help system. IDEA is packaged with Python interpreter and associated files for Python 3.5.3. Only 32-bit Python packages and libraries are supported. When using @python, the following rules will apply. The name of the function, that is the entry point in the Python script, must be identical to the Python script file name. The specified Python script should not contain executable statements outside of the defined functions. The specified Python script must reside in the custom functions library folder in the active project. The specified Python script must return a string value. Now that we have seen the rules for using Python with IDEA, the first task is to set up Python on our system. Go to python.org and download the Windows version of Python. Click on the installer and follow the instructions. The default installation goes into this folder, and please do not forget to enable this checkbox to add Python to the path environment variable so that Python can be executed from any folder. I have already installed Python 3.7.0. To verify whether Python has been installed correctly, start a command window and then type Python. Yeah, I'm getting Python 3.7.0. Even though IDEA version of Python is 3.5.3, I am using 3.7.0 as my own version of Python. It should be fine as long as we use standard language constructs. The next step is to make sure that all the Python packages which are available in IDEA version of Python are also available in our version of Python. You can click on this Python packages. IDEA installs the following Python packages. We have to use pip install to install all these packages one at a time in our Python. The first one is scikit-learn. The installation of one package will also install all the dependencies automatically. Yes, scikit-learn is successfully installed. Now let us type pip install matplotlib. Now we type pip install for the third package, numpy, and so on. Instead of typing one package at a time, there is another way to do it in one go by creating a text file with names of all the packages and invoking pip install -r idea python required packages.txt. So this will install all the packages in one go. If you encounter any error while installing all these packages through pip install -r, just run the command again. This way you can ensure that all the packages are installed in one go. Sometimes pip install may not work if you are a corporate user sitting behind a firewall using a company laptop or a PC. In such cases, try setting this environment variable set https underscore proxy equals domain name / username, which is used for login, colon password at proxy IP address colon proxy port number. Press enter. So set https underscore proxy should return the value. If this also doesn't work, please contact your security admin to allow you to go to internet to pull the required packages. Next, we need to set up a development environment for writing code. A search for Python integrated development environment gives you a lot of results, including PyCharm, Wing IDE, PyDev, PyScripter, Komodo, and so on. However, my preferred environment for development is Jupyter. If you would like to use Jupyter and follow along this video, you can go to install page and then follow the instructions using installing Jupyter with pip. When you run Jupyter, it creates a notebook file to capture all the Python commands and the output. I would like to create the notebook in the custom functions folder of my idea project. So I copy this path, go to a command prompt and then cd, right click. At this command prompt, you type Jupyter notebook and press enter. This runs a web server and automatically starts a web page. So I can create a new notebook, like new Python 3 notebook. So this is how a notebook page looks like. Here I can issue arbitrary Python commands and get the results for the same. Say 2 plus 3. Shift enter to execute 5. Say import sys.version. So I'll get all this Python output straight away. Let us start a new notebook, new Python 3 notebook, and try to recreate the get% function, example function which came with idea. The cells are having multiple types. This is the code type. I can go to markdown and then enter hash, recreate get% example. I can say run here to run this cell command. Now we are reverting back to code mode. I am defining the function get%, def keyword get% function name with numerator and denominator, 2 arguments, colon, press enter, is auto indented. Check for denominator being 0 if denominator equals 0 colon return n/a. Press enter. If the denominator is not 0, it will fall to the next line. Return double quote curly braces. The first element will be formatted in dot to 2 decimal points, floating points, and 1 percentage symbols will be added. This should be the format for numerator divided by denominator multiplied by 100. Shift enter to execute. Now we can invoke this function using 5 first parameter, second parameter 10, press enter 50%. We will check for denominator being 0. Get percent 50 NA. Suppose we go and change this to error and press Control Enter to execute, and then come here and then execute again, you will get error now. If you invoke the function using a different name other than the one which was defined, we'll get an error saying that this is not defined because this is not the same as this. Next, I would like to carry out a trivial task in IDEA and then carry out the same task using Python function just to demonstrate the workflow. The task is to check whether sales before tax plus sales tax is equal to sales plus tax or not. So let us create a criteria. Sales before tax plus sales tax put together is not equals sales plus tax. Validate yes. So we have 2 exceptions out of 900 records. Okay, let us read the criteria. Clear. Now in Python we will create a small function which will add up sales before tax and sales tax and return the total. Let us switch to our IPython notebook. So let us define a function called say plus. Define plus. So we are going to get 2 arguments colon plus enter total equals num1 plus num2 return total. So we will run this. Now the function is defined. Let us test it out. Plus of 5 comma 6 execute 11. So it is working fine. Now we have to create a Python file with a .py extension by copying this code and launch a text editor. I am using WinVI. You can use a notepad. So paste the code and then save the file in documents, my IDEA documents, IDEA projects, Python demo, custom functions, call it plus.py. Save. Now when you go to IDEA and then go to library, plus.py is now available to our project. Now let us create a virtual field, append, let's call it py1. It's going to be virtual numeric with 2 decimals. The criteria being @python plus sales before tax comma sales tax. Close. So validate. Invalid Python script. The specified Python script must return a string value. If you recollect, this was one of the rules for using Python with IDEA. So let us go back to our code. Return string of total. Save it. Validate again. Validate equation. Now when you apply this, we are going to get another type of error because we have defined this to be virtual numeric, whereas the Python is returning a string value. So that's why this equation returns a value that is different data type than the corresponding virtual field. So we need to convert it back into value. We are sending sales before tax and sales tax both numeric into Python and getting back a string value of the total and then converting into numeric value back in IDEA. Yes, it's working fine. So we have this value py1. Now let us check whether pi1 is equal to sales plus tax. Criteria: sales plus tax not equals pi1. Validate. Yes. Yeah. Now we are getting the same result with 2 rows being the exceptions out of 900 rows. Now let us delete this virtual field. Okay. You don't have to create a virtual field. You can apply the return value from Python directly in our criteria. Criteria: sales plus tax not equals @val of @python of plus comma sales before tax comma sales tax so we can see we get the value from Python and then convert it into value and use it straight away into our criteria condition. Validate. Yes. So again we are getting the same result of 2 rows out of 900 rows. Here we are not creating any virtual field but applying the return value from Python directly in our filter. For the next example, I'm going to use this PyTest file which has got 5 records. The task is to find the name of the day of the week of a given date, such as Sunday, Monday, etc. We will be looking at 3 different ways of doing it. The first method is to use the criteria. Let us define a new virtual field, append, call it x1, virtual character, say of width 10. IDEA has got a function under date time collection called day of week, which returns the number of the day of the week. For example, 1 for Sunday, 2 for Monday. However, we want the name Sunday and Monday, not the number 1 and 2. So we have to create a if then else condition. We say if the day of week is returning 1, we should show it as Sunday, and so on. Since we are going to test for day of week function multiple times, we have to use in the conditional section comp if function. So it has if condition 1 result 1, condition 2 result 2, and so on. So let us define this equation like this: at comp if day of week of x date equals 1, call it Sunday, comma if day of week of x date equals 2, call it Monday, and so on. If say comp if is 1 Sunday, 2 is Monday, 3 is Tuesday, 4 is Wednesday, and so on. And the last condition, if 1, it will catch all. Condition for if none of these matches, then it's going to be error condition. So validate equation. Now we got the name of the week rather than the number of the day of the week. The second method is to define a custom function. Click on criteria, click on this hash symbol which is custom functions, create a new function called DOW name. There will be one parameter. The incoming parameter will be a number, numeric, call it DOW number. Okay, DOW name, getting DOW number as a numeric argument, and returns a string like Sunday, Monday, etc. We have to declare a string variable to store the day of week name. So this is done using dim statement, dim dow string as string. This will be assigned to the function name. Dow name equals dow string to send the value back to IDEA. Now we have to determine the day of the week name. So we'll be using select case dow number case 1, then dow string equals Sunday, case 2 dow string equals Monday. The last condition is case else. We will call it error and select. Let us validate. There are no errors. Great. Now let us test it here. Suppose we send 1, we'll get Sunday. Case 5 is Thursday, so let us send the value 5. Thursday. Great. So let us save this. So this will be saved as dow name.ideafunc in our file system. You can see that here, dow name.ideafunc. This we can close. Let's close again. This will be available in our library as dow name.ideafunc. Now let us create a new field called x2, which is virtual character again with 10. In the parameter we are going to invoke a custom function by using hash symbol instead of @ symbol. So you can see that the dow name is already available. Dow name. Now we are going to send @dow of the x date. So we are taking sending x date to x dow and getting the day of week number and send that dow number into dow name custom function and get the names like Sunday, Monday back into IDEA. Validate. Yes, it's a valid equation. Execute, save. Thursday, Wednesday, Thursday, Sunday, Saturday. So we are getting exactly the same result. This is from IDEA parameter. This is from custom function. Unlike the complex equation used in @comp if condition, custom functions are much more easier to use. So it's also listed in custom functions dow name. When I click on it, you can see the usage. We can add our own help here. Criteria dow name, edit. In the help text column, this function accepts a day of week number and returns the corresponding day of week name. For example, 1 day of week number 1 equals Sunday, 2 equals Monday, and so on. You save this, and then when you go to custom functions, click on this dow name. Whatever text we have typed in as help text will appear here. So this is much more useful. Since it is defined as a function, we can use it in other files also. For example, INVDate. So I can append a field here, virtual character with 10 bit with parameter being hash DOW name at DOW of invoice date. So valid equation, save. Now we can see the day of week name for all the date. The third method is to use @Python function. Let us switch to our Jupyter notebook and create a function to return the day of week name. Define DOW name. We are going to get DOW number as the argument, colon. Let us create an array of all the DOW names. Python uses 0 as the starting index. So if the DOW number happens to be 0, we have to return the value error. If it is 1, Sunday, 2, Monday, 3, Tuesday, 4, Wednesday, 5, Thursday, 6, Friday, and 7, Saturday. This string will be split wherever we have comma. Now X days will have an array. X days of 0 will be error, X days of 1 will be Sunday, and so on. Now we just have to return X days of X DOW. That's it. Run. The function is created. Let us test it out. Say DOW name of 1. Execute Sunday. So let us even include the numbers as a comment. 1, 2, 3, 4, 5, 6, 7. So that we suppose we are looking at 4. Let's say 4, execute Wednesday. If there is some error, if 0, it is going to be error. Now the function is working fine. We have tested it out. Let us now create the DOW name.py file. Highlight the code, Ctrl+C to copy, start the editor, paste the code, and then save the file as file, save as documents, my idea documents, idea projects, @Python demo, custom functions, call it DOW name.py. Save. Now let us use it in idea. Double click, append x3 virtual character again with width 10, the parameter being @Python, within double quote DOW name, comma, we are going to send @DOW of X date. Now validate. Python generate the error. The indices must be integers or slice, not float. Understanding this error is an important learning point. Let us see what exactly is returned by DOW first. @DOW of X date, valid, yes. Okay, it's going to be virtual numeric because we are returning a number. So we are getting a number. So let us go back to our code and then test 5. Okay, it's working fine in Python. Then where is the error coming in? So what we can do, we can write a function to show what exactly Python sees when it is getting a value from idea. So let us define a function called def show same variable, which is coming in. We just return string of the variable. Run. So when we do show same of 1, it will return string of 1. So same of 1.5, it will return 1.5. So let us save this, Control C, custom functions, show same dot py, save. Now let us use it in IDEA. Let's create a field x4 virtual character 10-bit at Python show same at DOW of x date. Validate, yes, okay. It looks like a whole number from IDEA is viewed as a floating point number. Let us test it on the xint column. Let us create one more field, x5 virtual character, say 10 at Python show same xint. Valid equation. So 10 is coming back from Python as 10.0, 210 is coming back as 210.0. So let us look at the field manipulation window where xint is defined as a numeric with 0 decimals. So it looks like IDEA is managing numbers slightly differently. So what is 10 is actually 10.0. That's why the DOW5 is viewed as 5.0. Let us switch to Python notebook and then try out DOW of 1 is Sunday. It should be coming as 1.0. Now we are getting the same error. List indices must be integers or slices, not float. So to avoid this problem, we need to convert this floating point number into integer and use that as an index to return the value. DOW name, edit with idle. We just convert x DOW into integer of x DOW and then save. Let us switch back to create open new field x6 virtual character 10 at Python DOW name at DOW of x date. Validate. Now we are getting the correct result. So it is very important to be aware of the data types. So I have created a small function to display the data types of each column. It's available in library. It's in the local library custom functions, the show type.py. Let us look at the code. My IDEA documents, local library, custom function, show type.py. Right click, open with idle. It just accepts one parameter and then just returns the string of type of that incoming parameter, nothing else. So let us apply this in IDEA for each of these columns. Double click, append x1 virtual character, say 10 or 20 at Python show type xint. Okay, this script is not found because this is not in our library. Right now it is available custom functions folder of local library. So we can right click here and then copy to current project library. Now we have show type.py available to our current project library. Double click here, append x1 virtual character width 20 at python double quote show type accent. Okay, it says class float. Accent being whole number, it is viewed in Python as floating point number. Another x2 virtual character 20 at python show type x float. Save. It is viewed as float itself. The third column, append x3 virtual character 20 width at python show type x string. It's viewed as string itself. The last one is date. Double click, append x4 virtual character 20 at python show type x date. It is viewed as string. This function has more Pythonic flavor and it returns either the day of week or the month name from the same function depending on what parameter you send in. The first parameter is in the YYYYMMDD format, which is exactly the same as idea date format. And if the second parameter, which is what, is W, it will return the day of week name. If it is M, it will return the name of the month. This is already saved in date name.py. So let us apply this to our date column. Append x1 virtual character 20 at python date name. First parameter is x date, second parameter is within double quote W to get the name of week. We are using small w, but within the function it will be converted to uppercase. So let us validate. There is an error here. It said time data does not match format YMD, which is the Pythonic equivalent of idea date format. But let us test it out in our Jupyter notebook. Define the function date name, say 1st January of 2019 happens to be a Tuesday, so let us test for it. The first parameter is 290101. The second parameter is W. Execute. So we are getting Tuesday, correct? The month should be January, so we got January. So if it is not M or we set something other than M or W, we should get the message error. So this is working fine in Python, but it is generating an error in IDEA. The problem here is you have to read this carefully, and the exact problem lies here. This is a null string. It took me a while to figure out what is happening. That means even though it works fine in Python, when you send a date value into Python as an argument, the validation fails because it is expecting the date to be available to the function during validation. So the correct way of doing is we have to provide a default date value for this function to be validated successfully in IDEA. Let's create a temporary variable here. Temp equals, say, 1st of January 1900 0101. If p date is more than temp, then transfer p date into temp. Then use temp in our further calculations. So let us look for the month January, for the week Tuesday, second day is Wednesday, second. So this code works fine. Copy this code, date name .py, edit it with idle, and replace this code with the new code where we have this temporary variable assigned to just to provide a default value. File, save, go back to append x1 virtual character width 10 parameter at Python date name x date, we want day of week, validate. Now it is valid equation. Okay, so we got the day of week. Let us create one more column, x2 virtual character 10 at Python date name of x date. This time we are going to send m for name of the month, validate, valid. Now we are getting, so 01 is January, 04 is April, 12 is December, 03 is March. So using the same function we are able to get both day of week and name of the month. This example is slightly more advanced. This is called DOW delta. It takes a date and then we add required number of a weekday. So how does it look in IDEA? Append x1, we are going to get a date. Now we invoke at Python first, DOW delta x date. We want to add 3 Mondays. Now this at Python will return a string value, so we need to convert it back to date. So we have a datetime function which is character to date, so wherein you can convert a string value by giving a date format, convert it to a date. So we are going to ctod of this comma, format is yyyy mmdd, then validate. Yes, it is valid. Okay, let us just 18th of January 2018. Let us show the calendar here. January 2018 is here. So to this we are adding 3 Mondays. The first Monday occurs 1, 2, 3, 4 days later. Then the second Monday will occur 7 days later. Third Monday will be occurring 7 days later. So the result is 5th of February 2018. So 5th of February 2018. So let us take this example. 31st of March 2018. We added 3 Mondays to it. 31st of March 2018 happens to be a Saturday. The next Monday will fall 2 days later, and then it is already in April. 2nd of April, second Monday, third Monday, 16th of April, 16th of April. So this is how you can add arbitrary number of weeks, day of weeks to a given date. Since it is using relative delta, we can always use a negative value to go backwards. This also is a valid equation. So let us test 18th of January 2018. 18th of January 2018, we go backwards 3 Mondays. 1, 2, 3 days later, first Monday comes, second Monday, third Monday, going backwards. So 1st of January 2018. In this example called date delta, we can add a number of days, months or years to a given date. Since we are using relative delta, we can add positive or negative days or months or years in any combination to a given date. So let us see how it looks in IDEA. Let us add a new column, append x1. We are going to get back a virtual date. At Python date delta x date. We just want to add 5 days to the date. Now whatever comes in, we need to convert it into a date using YYYY format. Validate. It is valid. Okay. Now let us modify this. So we can say we have to add 15 days, but we have to go backwards by 5 months and add say 4 years. This is still a valid equation. So it is recalculating. This function called date cap is going to take 2 dates and then return the difference between the 2 dates in so many years, so many months and so many days, and also whether it is in the past or is in the future. So let us see how it looks in IDEA. It's like this. Append one field with the character value 16 at Python date cap, the date. Say let us find the difference of X date column along with 2018 June 30th, say for example. Validate. So valid equation. This date is 5 months 12 days in the past when you compare it with 30th of June 2018. Similarly, this date 23rd December 2018 is 5 months and 23 days in the future. In this example called num2 words, we will expand a number into equivalent words. For example, 1, 2, 3 will be 123 and so on. For this purpose, I have identified the unique words we will be using. Using RJS function, we pad the incoming number with the zeros on the left side. This is how it works. Say we have a 5-digit number, and then we can dot RJust. We want 15 digits padded with 0. If you execute, you can see that it is right justify this number, and paired zeros on the left side. So let us create the function and then invoke it. num2 words 1 2 3 4 5. Execute. See, 12,345. So we have bigger number, 123,700,000. So you get the idea. So this is to expand the number into equivalent words. So let us save this function. Control C, start the editor, paste the code, save as documents, my idea documents, idea projects at Python demo custom function, call it num2 words.py. Let's switch to idea and then so add a column, append x1 virtual character width 100, parameter at Python num2 words xint, valid equation, save. It's 210, 31, 17, 220. So we got this number. Let us create the same formula for the float column. x2 virtual character 100 at Python num2 words xfloat, close, validate, yes, okay. 20.34, 120, 120.12, and so on. Now let us take a look at the code. You can see that I have taken some effort to create this function by identifying the unique words and then even creating another function which will be invoked again and again, once for trillions, once for billions, millions, and so on. But this was not a smart move. If you are a smart programmer working with Python, the first thing you should do is to search for a package which was already developed by someone which can do the same task. Say I'm going to search for Python expand num2 words. How do I tell Python to convert integers into words? Say this is a question. Let us look at the answer. The inflect package can do this. Pip installed inflect and then import this inflect num2 words, the number, and you get the answer. So compare this to my code, which is so long. It's not a smart move. So let us try this out. Let us first install inflect package. Pip install inflect. Yeah, I have already installed the inflect package. Let us switch to our Jupyter notebook. Say import inflect, execute. P equals, it instantiate the engine, looks like inflect dot engine, then p dot number to words. So let us copy paste this now. Control C to copy, paste, execute. Just 3-line code to replace 40-50 lines of code. This is the smarter way of using Python. So let us create our own function to use inflect. Diff expand the number colon import inflect, instantiate the engine inflect dot engine, return p dot number to words that number, execute. Now let us just invoke the function expand 1 2 3 4 5 6 7 8 9. Execute. So even if it is having a string with comma in every third digit to denote thousands, millions, billions, trillions, still works. Okay, the output is coming in small letters, so we can just return this string to title case. If you are very familiar with Python, instead of instantiating separately, you can even just return inflect.engine dot number two words, the number, and convert it to title case. So let us comment it out, and yes, it still works. So you just need 2-line code instead of this many lines to if you write it by yourself. So let us save this function as expand, Control C, editor, file, save as expand.py. Let's go to, so let us create another column, append x3 virtual character 100 at python expand exit. Python generated the following error: no module named inflect in the Python version of IDEA. Now we have to make this package available to IDEA. Let's go to the file system and look for this package in the main version of Python, which is available under C drive, users, user, app data, local, program files, programs, Python, Python 37, lib, site packages. Look for inflect.py, right click, copy. Now we have to copy this into the site packages folder of IDEA. C drive, program x86, caseware IDEA, lib, site packages, right click, paste. We have copied inflect.py into IDEA version of Python. So let us go back to IDEA and then validate again. Now it is working. Okay. Hope you find this video useful. Thanks for watching.